A small body is oscillating vertically on a spring in a laboratory so that the height h centimeters of its center above the floor, t seconds after measurements began, can be modeled by h is equal to a cos b t plus c plus 72. The maximum height of the body of 120 centimeters is first reached when t equals 4, and again when t equals 10. So if this is the floor of the laboratory, the mean line for the oscillations is 72 centimeters. So we can tell that from the plus 72. So it's going up and down, and we know that it has one maximum here when t is equal to 4, and another one when t equals 10. The maximum height is 120 centimeters. So that makes the amplitude 48 centimeters. So A is equal to 48. Going from t equals 4 to t equals 10 tells us that the period for the function is 6. Now we know that period is 2 pi divided by b when the b is here in the formula. So 6 is equal to 2 pi divided by b. B will be equal to 2 pi divided by 6, giving us that b is equal to pi by 3. Now, if this curve were to continue and come back here, the next maximum in this direction would be at -2. Now, obviously that never happened because the time started at 0. However, it does tell us, because the cosine normally has its maximum at 0, that the curve has been translated 2 units to the left. That would make the c here equal to 2. The ceiling is 2.1 meters above the floor. If d is the distance from the center of the body to the ceiling, determine the relationship between d and t as a sine function. So, we have our object going up and down, and the ceiling is up here, and that's going to be 2.1 meters or 210 centimeters above. So this distance here is going to be 210 take away h. So that's 210 take away 48 cos pi by 3 t plus 2 plus 72. So that's 210 take away 48 cos pi by 3 t plus 2 take away 72, which is 138 take away 48 cos pi by 3 t plus 2 pi by 3. Now think about the sine and think about the cosine. The cosine is the sine moved pi by 2 to the left. In other words, cos A is equal to the sine of A plus pi by 2. So this one's going to be 138 take away 48 sine pi by 3t plus 2 pi by 3 plus pi by 2. And that tidies up to give us 138, take away 48 sine pi t by 3 plus 7 pi by 6. At what time is the centre of the body first equidistant from the ground and the ceiling? So halfway, which is 210 divided by 2. So this is the distance. So what we want to do is solve 138, take away 48 sine pi t over 3 plus 7 pi by 6 equal to 210 divided by 2. Now that's going to give me an infinite number of solutions, but we know that the period is 6. So I'm going to restrict it to t times between 0 and 6. So I've typed that into the calculator. You can see that I've got the equation here, and then I've said given that x is between 0 and 6. I left out the less than or equal to just there. And if we execute on that, we get 3.22 and 4.77. And it looks like those are the only two solutions. So the first time is the 3.22 seconds.